Course 2, Lesson 3 today. We're going to be starting on page 20 in your textbook. And Lesson 3 deals with unknown numbers in addition, subtraction, multiplication, and division. So today we're going to really start into algebra. And basically, algebra is different than mathematics. It's a branch of mathematics, but in math, we would say 2 plus 2 equals 4. Algebra says one of these, we're going to pick this one, is an unknown or a variable. So algebra would say 2 plus x equals 4. Well, we know that's going to be 2, but how do we know that? Okay, I'm going to show you a simple way to find this answer of x every single time. So let's go over to the equation and let's rewrite this. 2 plus x equals 4. All right, generally speaking, I want x to stay on this side of the equal sign, which means that this 2 is going to have to come over here. How do I do that? How do I get 2? Can I just move it? Well, I actually have to do a subtraction problem. I have to subtract 2 from both sides of the equation, which 2 minus 2 is 0, which cancels that out. So I have 0 plus x equals 4 minus 2. Or, since 0 really doesn't matter, x equals 4 minus 2. Well, x equals 4 minus 2, so 4 minus 2 is what? 2. So we can put 2 back in the equation for x and make sure we can solve here. That is the basis for algebra. All right. Now, if you look at your textbook, page 21, at the very top, it says an equation is a statement that has two quantities are equal, and then they show a couple of examples of what that looks like. So here we have 3 plus 4 equals 7. 3 plus 4 is 7, and that equals 7. All right. So let's look at another example that they give, which is 5 plus a equals positive 9. All right. So what is a? Well, we can do simple math and see that 5 plus 4 equals 9. We know that because of simple math. But if we really want to figure this out, we're going to subtract 5 from both sides. We're going to drop a down, and a equals 9 minus 5, or a equals 4. So this is how we're going to do our algebra math. This is literally addition, right? This is the easy stuff. This becomes the harder stuff. All right, let's go to example 1 in your textbook, and I'm going to do A. A says you have n plus 53 equals 75. Okay, so I already have n over here, so I need to get 53 on this side. So how do I do that? Well, I'm going to subtract 53. And the reason I subtract 53 is because 53 here is positive. So I want to completely erase this. So the only way to do that is subtract it. But what I do there, I have to do on the other side of the equal sign. So I have to subtract 53 on this side of the equal sign. So now I have n equals 75 minus 53. Okay, 75 minus 53, that's an easy problem, right? 5 minus 3 is 2. 7 minus 5 is 2. That means n equals 22. And there's my answer. All right, let's try B. B in that section says 26 plus a equals 61. Well, again, if I want a to stay on this side of the equal sign, what do? I'm going to subtract 26 here, and I'm going to subtract 26 here. This cancels out. I'm left with A equals 61 minus 26. 61 minus 26. I'm going to borrow, right? So 11 minus 6 is 5. 5 minus 2 is 3. So A equals 35. Now you might say, okay, but how do you know? Well, if I put 35, if I put this answer back in for A, I should get 61. So let's try that. 26 plus 35. 6 plus 5 is 11. Carry the 1. 2 plus 1 is 3, plus 3 is 6. There it is, 61. So I know that 35 is correct. Okay? So those are the kinds of problems that you're going to be working on. Let's do it with negatives. Okay? So turn the page, example 2, and negatives are the opposite of addition. So example 2a says p minus 24 equals 27, or excuse me, 17. Let's try that again. A is p minus 24 equals 17. That's the one. All right, so instead of having an addition sign, we have a subtraction sign. So we still want p on this side of the equal sign. All right, so we still want p equals 17, but we're going to add 24 to get rid of it here, and we're going to add 24 here. So what we're left with is p equals 17 plus 24. All right, what does that equal? Well, 7 and 4 is 11, so carry the 1. 1 plus 1 is 2, plus 2 is 4. So p equals 41. So it's the exact opposite. Instead of subtracting 24, this time we added 24 because up here we had a negative 24, so we had to do the opposite, so these two cancel out. Essentially, we want that to equal 0, so that p equals 17 plus 24. Okay, so that's the subtraction. Pretty easy. Let's go to another look, maybe a little bit more algebraic. In example 3, we have 12n equals 168. All right, anytime you see this, 12n, and they're right next to each other with no space, that means that they are being multiplied. It's like 12 times n equals 12n. In other words, it's just being multiplied. So in order to get n by itself, since it's being multiplied, the opposite of multiplication is division. So what we're going to do is we're going to divide by 12 both sides. And when you do that, you can cancel out those 12s. Notice in division, we don't have to deal with negatives and positives. Okay, we just divide by what it is. But what we do here, we absolutely have to do here. So what's left over? We have n, because n didn't cancel out, equals 168 over 12. Well, you know what that really means. That means a division problem. 12 divided into 168 goes into it one time. We get 48 and 4 times, which is 48 minus, that gives us 0, so our answer is n equals 14. So when you see a multiplication problem like this, 12n equals 168, again, we divide both sides, cancel these out, and we're left with n. Okay? Sometimes students leave it in this format, but I want you to go all the way through and do this long division. Okay? All right, one more example. Let's go to example 4. Probably the most challenging. A gives us a unique look. We have a over 3 equals 15. Okay, so when we have something like this, and a is being divided by 3, We need a large number up here because the division problem is 3 divided by something, and it's going to equal 15. All right, so if there is an A on top and you have the number down here on the bottom and 15, that means you're going to multiply 3 times 15. Okay, and 3 times 15 is equal to 45. So A equals 45. So 45 over 3 equals 15. In other words, if we did 3 divided into 45, we would get 15. There it is. All right, so it looks a little bit weird, but we can still solve for A. What if it's on the bottom? Okay, B shows you 64 over A, I think they call that B, let's call it B, equals 4. This is going to be a small number, and we're not going to multiply when the number is on top, and here we divide. So 4 into 64, right, is 16. Okay, and so again, we can find out. So B equals 16. So with this equation, it's a division problem. With the one prior, A, it was multiplication, and then the other ones were addition and subtraction. Okay, so that's your lesson. You're going to see a couple of practice problems down there. You can choose to do them if you want, or you'll find these from number 7 in your lesson on page 24 all the way through number 14. All right, so this is going to be the new section that you're going to be working on. Okay, all right, you have your lesson to do.